Hi, everyone. Just wanted to take a moment to talk a little bit about proportional parts and parallel lines in relation to different figures. So really, we're going to kind of look at three different things as we go through this section. So the first part that we're going to look at is something called the triangle proportionality theorem, which you might also see as the side splitter theorem. They mean the same thing. Basically, what that theorem states is that if these are parallel here, then these will be put in the same proportion. So 4 is to 8 as x is to 16. All right. So if we are to set this up, we could set it up 4 is to 8 as x is to 16. Well, this is actually pretty easy, right? 4 is to 8 and this is 16, so it's just going to be times 2. So your x is ultimately going to be equal to 8. Okay. So that's all we're looking for in that one. Let's just confirm. See, by the triangle proportionality theorem or the side splitter theorem, 4 is to 8 as x is to 16. Multiply it out, you get x equals 8. That one is also pretty visual, right? So, 4 is to 8 as blank is to 16. That one's pretty straightforward. You could probably do that without even having to multiply out. So whatever works for you, you can use. All right. So let's look at our slightly more difficult one. So in the diagram below, we know that MJ is parallel to LK, so we can use the triangle proportionality theorem with the side splitter theorem. We know that all this information about the sides, and our goal is to find the length of HK, so we want the whole thing. So there's a couple ways you could set this up, and both of them will ultimately get you the same answer. So we can use the same theorem that we just used. 7 is to 21 as x is to 15, right? So clearly if 7 is to 21, that simplifies to a third, right? So x has to equal 5. So that would be 5, right? So that would make this whole thing 20, because 5 plus 15 is 20. Alternatively, what you could do is, we know that things have to be in the same proportion, right? So if we know that things need to be in the same proportion, we could set them up just with doing the whole side. So if we are to set that up, 21 is to 28, as 15 is to the missing length that I'm missing. I'll call it y, right? We'll say the whole thing is y. HK, you know what? I'll just call it HK. Okay, now unfortunately this is a bit more work. That does simplify still to 3/4. If you can simplify, go for it. Is to 15 over HK. Now this would make it 3HK is equal to 60. So HK will equal 20, right? So no matter what, your answer is going to be 20, but that's just showing that there's a couple ways that you could set this up using the different proportional parts. All right. Check. My answer here is 20. And there you have it. Okay. And again, they did it this way, but you could find this part and then add it either as well. Okay, so that's the triangle the triangle proportionality theorem with the side splitter theorem. The next one that you can use is the triangle midsegment theorem. Now, the triangle midsegment theorem is basically very similar to the other thing, except it's a very specific situation. And what do I mean by that? Well, by that, I mean these are now midpoints. Okay, so this is a midpoint and this is a midpoint. So we're specifically taking a certain length, right? So this is half of the whole thing. This is half of the whole thing because this is the midpoint. So that means this by similar triangles is also half of this. So I know that WX right here, that's going to be 37 minus 4x. I know TV is 81 minus 9x. Now I know essentially what this is saying is that this is half of this. So this times 2 has to be equal to this, all right? So that is ultimately going to be, minus 91. 9x. Oh, let's just clear it. So this would be 81 minus 9x is equal to 2 times 37 minus 4x. It's very important that you remember the 2. Alternatively, you could have divided this by 2, but that wouldn't have made life any easier because ultimately you had 81 and 9, neither of which are divisible by 2. So we have 81 minus 9x equals 74 minus 8x. I'm going to bring that over there, that over here. What is that? 7 equals x. So now I have to plug it in, and I have to find TV. So 81 minus 9 times 7 is going to be 81 minus 63, right? So what would that be? 17, 18. Okay, so it should be 18. Let's double check, make sure I did my math right, and we are good. Okay, so that is ultimately all you're going to do every single time. Let's do another one just to be certain. Okay. Again, we have that this is a midsegment. So we know that this is half of this. So I'm going to multiply this times 2 to equal the other one. So 2 times 9x minus 20 equals 5x plus 12. So 18x minus 40 equals 5x plus 12. 13x will equal 52, which is nice, so that makes x equal to 4. So now I'm going to plug it in here. AC is 5 times 4, which is 20, plus 12, which is 32. And there you have it. Now, there is one other type of question you could end up with, and it has to just do with angles. So whenever you see these, as a reminder, these are parallel lines, right? Because this is a midsegment as part of the triangle midsegment theorem, this line is going to be parallel to this one, okay? That's part of the theorem. So if you see a midsegment, you know these are parallel. Now, because these are parallel, that means that these are corresponding angles, so they are congruent, and then these are corresponding angles, so they are congruent. Okay? So what are we looking for? PQM is 8x plus 48, and then L and Q is 6x minus 6. I'm sorry, 62 minus 6x. Now these are congruent, so you set them equal to each other. And again, that's because these are parallel lines by what it means to be a midsegment. So they are corresponding angles. And corresponding angles, as we know, are congruent when you have parallel lines. All right, so that makes that 14x equals, and if I subtract that, I actually believe that is going to be 14. So x will equal 1. I plug it in. 8 plus 48 is going to be 56. So the answer should be 56. Remember, you have to plug it back in. And there you have it. All right, last thing that we need to talk about will be parallel lines cut by transversals in terms of proportionality. So when you are given something like this, if you have parallel lines that are cut by two transversals, we ultimately would know that these are going to be cut in the same proportion. And because they're going to be cut in the same proportion, we can set it up as such, okay? So 4 is to 24, sorry, as x is to 18. We can solve that. Well, I'm going to simplify this first. I don't want to deal with this. So I have 1 over 6. All right, so that gives me 18 equals 6x, x equals 3. Okay. You do have to be careful because depending on the problem, if it ends up saying, I do want to just make this a little clear. If it says that this is congruent to this, then you automatically know that this one will be congruent to this one. Okay? So if you do come across that, you will be able to use that information. That just also comes with a proportionality. So let's do another one. Okay. Again, we know that x is to 6 as 11 is to 33. Well, that's easy. X is to 6 as 1 is to 3, right? Simplify. So 3x equals 6, x equals 2. Don't question how we have a 2 and a 6 and 11 and a 33, but point stands. Ooh, submit. All right. And there you have it. So there are some different things. And I do, again, just want to reiterate on this one. If you come across the information that this and this is congruent, and then this, that means that this and this would be congruent. Okay? All right. So let me know if anybody has any questions, and have a great day.